Good morning, good evening, everyone. Welcome to the PAS BA webinar marathon. We're excited that you could join us today for Jordan Goldmeier's session on creating outstanding spreadsheet models. My name is Jody Roberts. I'll have a quick few introduction slides before we hand over to Jordan. Just around audio and sound. If you require any technical assistance, there's a Q&A pane. Please raise your hand or type in your question. The pane is located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation, so feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I will read your questions aloud to the speaker. You're also able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. If you'd like to hear more, if you like what you hear in these webinars, make sure to attend the PAS Business Analytics Conference taking place from May 2nd to 4th in San Jose, California, with hands-on learning opportunities from data and business analytics experts and a variety of networking opportunities. The PAS Business Analytics Conference is a great opportunity to gain valuable skills and advance your career. All webinar registrants get $100 off the two-day pass. Just use discount code BA Marathon during registration. Visit pasbaconference.com to register, as the discount code expires January 1st. If you're interested in accessing other pre-educational content, the PAS organization has a variety of virtual chapters which offer free webinars to the members every month. Check out the upcoming webinars and recordings of past webinars from our Business Analytics, Excel BI, Business Intelligence, Big Data, and Cloud virtual chapters by visiting www.sequelpas.org/VC. And now time to hand over to Jordan Goldmeier, who will be showing us how to do some great visuals. Over to you, Jordan.
Well, thank you so much, Jody, and I'd also like to thank PAS and Angie in particular for putting this together. This really is a great lineup, and I'm a big believer in this organization, and I really like PAS, and I hope to see everyone at the PAS Business Analytics Summit later, or I should say earlier next year. And just a little bit about me. I am an analytics data scientist professional. You know, there's various names: analytics professional, data scientist. I live in this space, so let's just say that. I've written 2 books, Advanced Excel Essentials and Dashboards for Excel. If you're interested in creating dashboards with Excel, that's my newest book. I urge you to go check it out. There's a lot of great material in there, some of which is actually going to appear here today. But really, that book really applies a lot of hands-on approaches. And I've done a lot of this before. I provided training and consulting for NATO and Financial Times and several other organizations. So this is something I very much enjoy doing, and I very much enjoy doing these webinars. So I assume you're all very much familiar with spreadsheets because you chose this webinar. Have you heard you know, about the pivot table? Walks into a bar, bartender says, "Hey, should I start a new tab?" Now I know you're muted. I assume that we're all laughing at that terrific Excel joke. But let's really focus on why I'm here today. There's really 2 goals out of this presentation. These are very important ones, and I don't have them written down because I have to force myself to talk about them beforehand. And the first goal of this is really, why do we do what we do in Excel? Why do we build models the way we do? And how could we do it better? Now, I'm going to advance some things in here, some of which are visual, as Jody has pointed out. I'm going to advance some things in here that really you may end up disagreeing with, and that's actually very important that you do disagree with it, because to disagree with it means that you've thought about it, and that's really what I'm trying to get us to do today, but not just today, really out when we go out and build our work, because some of us may have come from accounting, some of us may have come from finance, engineering. We've all learned how to do something a certain way, and often that certain way that we've done is because we've always done it, and that has formed convention. And what I want to do is sort of challenge some of those conventions, because I don't really see that they return value in your spreadsheets. And you may be wondering, well, who cares? And that brings me to my second point, because this is very important at the moment we are in within the BA space and spreadsheets in particular. Because right now we have these big vendors, big vendor platforms coming in saying, hey, your organization lives in spreadsheet hell. You are creating work that does this, it's not traceable, it doesn't always output what you want. And the thing is, we would love to sit here and say, you know, they're very wrong about that, but the thing is that they're not wrong about that. That's actually a very interesting critique because we all are doing things different ways, and efforts to sort of centralize ways to create spreadsheet models have manifested in EuroSprig, and then there's another spreadsheet group, and it's very rigid, their rules that they're presenting, and a lot of them, again, are being based off of conventions that have come out of things like accounting and finance, and not that there's anything wrong with that, but really they haven't always been applicable, or they've always just been the way that accountants think. No offense to accountants, I did study accounting and used to be one. But they're really products of the loudest voices and perhaps the users who most used Excel in its earlier days. So I can't obviously present a million different rules here today, but what I really want you to do and drive home is to think about why are we doing what we're doing, and maybe we can come to things that work, things that don't work, or at least we understand what works, what doesn't, and why. And that why is the most important takeaway here, because I can't come up with rules for everyone in every organization, but what I can at least advance to you is that the real way we're going to save this and show that Excel is a robust platform, that you don't have to spend all that money on a big BI vendor platform that's going to cost more than it delivers. We all know that. The way we can do that is actually going down to the atomic level and saying, well, why do we do what we do? Let's see if we could do it better. And again, you're welcome to disagree, and if you're not disagreeing, well, then I'm not really doing my job now, am I? The point being is that we should put thought into what we do, and that is how we create outstanding spreadsheet models. So let's get right into it. I've really split this up into 3 different areas. You'll notice that some of these areas overlap, so much of that is about convenience of categorization. And I only bring that up because it really isn't necessarily important where they are classified in these different areas. It's really more important that we think about them. So the first is layout and design. So we should create work that is easily updatable, and it mitigates user error. I'm going to talk about user error and errors in general in the spreadsheet as we go through this, because often we build things that will prevent errors, but we also build things that will not show us when errors happen. And I think that we're often afraid that errors are going to be in our workbooks, but errors are important. They need to be shown. They need to be ramified up so that we can see them immediately and take remedial action, whether the error resides in the data or whether it resides in the work that we've done. But in terms of presentation, we don't want to add clip art, distracting logos, word art. Those are things that I've always advocated against, and not just for the reason that I don't like them, which I don't, but for the reason they actually add bloat to our spreadsheet, and we'll go into that. Mechanics, slow formulas. Some of you may know about volatile formulas. Volatile formulas are often very useful, things like indirect offset, but they also slow our spreadsheets down, and they can make spreadsheets grind. And so when those BI vendors come in and they point to that and say, well, look how long it's taking for this to load, they're not wrong, but rest assured there are ways around it if we think through these problems and we don't just keep using offset or indirect, because that's what we were taught. We should also build our formulas in a way that they're easily understood when we pass our work along. So I call that semantic development. And again, we'll go into that a little bit later here, but there are ways to create formulas that actually describe or at least hint to what they're doing, so that when we pass the work along or when we look at that work later on, we have a good idea of what's going on. And then data visualization and presentation. Now, this one we will always have over the vendors, right? Because they don't practice good data visualization principles, and to an extent, neither does Excel. So that's really on us. And if anything I can have you take away from here, it's that Excel's not going to do this for us or fight this battle to say, hey, don't spend that money on those big BI platforms. It's not going to develop the work for us or construct it for us. We need to do it ourselves, and we need to arm ourselves in that type of thinking. So I've made this presentation a lot about models because that's the world in which I live. But I want to tell you that you can extend this beyond models and really into reports. Obviously, reporting is a big part of model building. But let's just focus here so we can understand what I'm talking about with models. So we know models are simplified versions of reality. That's pretty important because just because a model says something doesn't make it true. It's just a product of its own assumptions. Everyone can nod and agree to that, but it's worth reminding ourselves. It's been said that all models are wrong, some are useful. I would add that most are not, because we treat them as realities. when we shouldn't. We need to understand that some models will even provide contradictory information. Again, that is a product of assumptions. Even contradictory results can still both be correct within the locations of which they were produced. So what is a spreadsheet model? Well, that's an easy one, right? It's the extension of applying models to spreadsheets. And again, people don't think Excel is necessarily a place for robust models. They think R, they think MATLAB, Python, different spaces like that. And I want to say here, as an R user, I want to say no, spreadsheets definitely have their place. Now, why use spreadsheets at all? Well, these are easy answers, right? They're everywhere, specifically Microsoft Excel. They're relatively cheap, especially if you're now part of that Office 365 program. They're easy to use, the learning curves are not strong, and they allow you to turn work around quickly. And before moving forward, I actually want to add another reason why we want to use them is because often when we produce work, and if we've spent a lot of money on it, again, going back to the investment into these platforms, when they produce models and they have results, it's a lot harder to go back on those results when you've spent a lot of money on it and you put a lot of time, effort, and resources. Well, Excel gives us the way around that because it's very easy to use and it's very easy to turn things around quickly, and we can change things and go back if we need. And if nothing else, even if the problem is too big for Excel, it's worth prototyping it in Excel just so we understand what we're asking for when we are asked to spend more money on it. So,
Hey Jordan, just before you're going on, Jordan, sorry to interrupt. Your volume is up, it's fluctuating up and down. So it's like you're moving away from the microphone, so people can't hear you properly.
I understand. I get very animated. You can't see me on my side, but I probably am moving around a lot. Great. So, just let Jody know if I do that again, and we will correct it. So there are three goals here, what I call developmental memory or development memory. So that is, we need to build in a way such that when we hand it off to someone else who's not seen it, they can pick it up. Now, there's another side of that, and that's the you that you might be handing it off to 6 or 7 months from now. So we need to build in a way that helps us, or at least ingrains or builds in what we've done and what the model does within our Excel formulas and within our work. And it actually is not as hard as you might think to do that. We also need to have model transparency. That means we need to be able to show someone the underlying methodology of the model. And we need to be able to see the errors quickly. So we can't just wish those errors didn't happen. We can't just move them off somewhere else. We need to be able to see them when they happen so that we're able to tackle them and get rid of them. And finally, as a product of both of these, we need to have model efficacy. And this is not something that you can engender in Excel. It's something you have to work on yourself. Specifically, by building good models, you are creating confidence in them, and when you present them, other people will believe the work that you've done, and they will have confidence that it can do what it says it can do. And here is where the BI platforms fail, because they often promise a lot but don't really deliver. They trick us with their graphics, and then we go and use them and realize, hey, this is not exactly what we had bargained for. Again, you have that control in Excel to deliver what you want quickly and effectively. So that's what we want to address here. So in terms of layout and design, we need to follow good naming convention styles. And we're going to go through these as examples. So this is really just an introduction to what we're saying. So that means clear and descriptive names for files, worksheet tabs, and ranges, named ranges. So much of how we name our files is really a product of our organization. It's a product preference. There's ways we do it which are very much ineffective because they don't keep a good archive of what we've done. We also need to implement a good model layout, so we need to separate raw data, which obviously should never be touched directly. You should always do something on top of the raw data within your Excel model, and then how that flows through the presentation. We'll talk about how to do that here soon. We need to take a look at worksheet tabs. Much of the construction that we do in Excel, many of the models that I've seen that have been handed to me, have an insane amount of worksheet tabs. Very few people think about this, but those extra tabs, that backup work, those things that you're saving, those add bloat to the file size. They're what makes it so long to load up when you first open Excel. And in addition, if there's extra calculations on them, in particular, volatile functions and formulas are a very heavy pivot table that's not being used or for some reason existing on another tab. That is extra bloat that Excel has to carry. So to the extent we can condense our work, we should try. We should always keep formats organized and clean. Again, this isn't just about having a simplified aesthetic, though that is important. It's also about every little bit of extra bloat causes Excel's file size to go up. That's one bit of calculation that's going to be hampered. It's just every extra thing sort of works against us. And sufficient instructions. So I've also seen this practice of putting detailed instructions in the spreadsheet. Again, a lot of extra bloat. We can move these to other places. So as far as spreadsheet file naming conventions, we should always use complete words. Forget about those abbreviations. Only you know. Remember, you really need to describe what you're doing. So I always say 2 to 3 words. Keep it descriptive. If you're going to do abbreviations, they should be proper nouns. So if you have a model that you've abbreviated, that makes sense, but don't abbreviate the word example as EX. That could mean different things in different contexts. It's not very conducive to understanding what that file is doing. We should use numbers to show incremental versions in the latest file changes, and we'll see an example of that in a moment. And I don't particularly like using dates and file names, but I understand the need for it. If you do use dates, make sure it's well delimited, and by that I mean, hopefully you can see my mouse here. We are using dashes to offset that date. We're not using just one string of numbers because that is not clear as to what it's doing. Now, a lot of us don't think about this. We think, oh, let's just build these files for ourselves. We know what they're doing, but that all sort of contributes to the problem, now doesn't it? So let's just take a look at a very clear example. If I look up top and I think to myself, what file, I'm just looking at this top, and these are effectively the same files, and I'm looking inside our Windows Explorer. What file is the latest one, just looking at this, and which is the earliest one? Well, it's kind of hard to figure out very quickly which the latest file that we've worked on is. And in fact, it's the sales dash with this date, and then I have my abbreviations here, and I've added a B because that's the latest one I've done on that date. This is not effective file naming conventions. So this actually seems like it's not a data visualization item, but it actually very much is. If we go down, here I've used 1 through 8, and I don't actually add the date because that is stored within the file itself. I'll leave you to decide whether you want to do that or not, but the point being is that here I have an effective archival of the work I've done. And at the same time, this actually uses data visualization principles because the latest one is at the bottom, the earliest one is at the top, and I can understand incrementally how I progress. At this top one, I can't. And by the way, if you are keeping things like this parentheses 1 and this copy in here, remember that this is professional work, so please don't do that. Please use the file names to describe exactly what you want it to do. Now, moving from file names, we actually see this practice in worksheet tab names, because here I have a top one. I pulled this from a real file. We have underscores within these, but we don't really need underscores within our tab names because this isn't DOS, and we are able to use spaces. So many people will, just because of the organization they work in or the culture or what they've learned, what they'll do is they'll add underscores because they think, well, this is data and we need to do that, but we don't in fact need to do that. And I would urge you not to, because this is not clear as I look at this what's going on. This is this bottom one.
Jordan, sorry to interrupt. We're losing you again.
Sure. So my volume isn't going well?
Yeah, you keep fading in and out, so we're losing you.
And it looks like my cord came unplugged. Okay, so let's try this, and hopefully this might be better. Okay, so worksheet tab names. We need to focus on naming things they are and not use these sort of programming variables and engineering variables that don't really describe what's going on. So let's talk about proper model layout. Now, if you've done some database work before, if you've done other programming before, this is actually very similar to N-tier structure, but I like to formulate it in this sort of rhyming convention. We have information, that's where your back-end data is going to reside. You have transformation, that's where you perform the work and the calculations on top of that data, and you have presentation. So what I want to suggest to you is the way you should build your models is that you should always put your data in the information, and then you do some transformation work on it, and it flows through the presentation. And we keep those separate, and we'll talk about why here in a minute, but let's just take a look at this conceptually. We have our information over here on the left that flows into our transformation. That's a pivot table. Now remember, pivot tables don't in fact change the data that's on the information. They just create a new way to present it. They transform it, and then from there we have our presentation. Now, at no point in time here does this actually change the underlying information data. And what this allows us to do is keep a separation of concerns, because in the presentation, this is just a product of what's happening in the transformation. So if we see an error on the presentation level, we know we can jump back to the transformation. If the error still resides here, we can take a look at information and see if it begins there. If it doesn't, we can actually conclude it started in transformation. And the important point here is that our errors are propagated. That is, they're ramified through the entire process. They're not separated. So we have to think about, why does this matter? So we keep better organized work in doing this. At each step, we can see what we've done. In this consistent logical pattern, if we follow this, it helps us keep our models transparent because we always know how it's flowing. So it flows from the bottom, that's our data, up to the presentation. So we also need to understand error propagation. So we need to make sure that the way we build is going to create errors when they exist. So again, if you see an error in the transformation, you can reasonably conclude it doesn't exist at the presentation layer because it exists at the transformation layer, and it doesn't. And if you haven't found it at the presentation, then you've concluded that. And this allows us to find those errors quickly and allows us to judge them and figure out what we need to do to take care of them. And it also keeps the integrity of the back-end data. So that raw data is never touched. I know a lot of people have heard not to touch that raw data that you paste in from the database or that's been pulled from the database, but I think in practice it's worth reminding ourselves. Now let's talk about clean and organized layout. This is what I would consider not clean and organized layout. Not only is it not really aesthetically pleasing, we have a lot of extra things here, and we'll talk about in the data visualization section why 3D is not very good. But keep in mind all this extra formatting, this is bloat on the file size. Now here this example is simple, but we all know that real life is not so simple and that our models in Excel are often very complex, and every little bit that we add, we are hindering our ability to deliver a fast and speedy model that's going to produce results quickly and effectively that management wants. And I can tell you they probably don't want pictures of pencils and binders, and you don't really probably need a giant byline here. So if we look at this change here, we see that it's a lot more simple, but it actually gets the point a lot more quickly and effectively. And the best part about it is that it doesn't carry any extra bloat. Only the information that's required to present is here in being presented. So again, organizations have different rules. You may not be able to get away with getting rid of that clip art that you know you don't want there, but it's worth pointing out to your boss or your colleague or the person who says, no, they really need this to understand that work, and we'll talk about that later, how to address that. At least you can say for now, hey, we're doing a lot in this presentation or in this model. Why are we adding this extra bloat that we even agree here doesn't really do anything? So again, clean and organized layout is not just about removing bloat, but it's also about making things easier. We often see that this sort of formulation where we take titles and we make them curved. I'm not sure why. We know from data visualization research from Stephen Few, Edward Tuff, that this does not help, but actually, in fact, inhibits our ability to understand what's going on. Make sure that you make these flat and easy to read. Remember, if it's not easy to read as you're looking at it, if you're craning your neck, then it's not natural. And the work you should do should be a natural extension of the underlying problems that you're being presented. And I'm going to keep going back to that. That's a major theme of my work. But remember, technology is just really the tool to help us present the results of a model. The technology itself needs to only help us naturally extend the underlying message. To the extent that we've overcomplicated with technology, we've not served ourselves well, and we've not served our businesses and organizations well. So if I just look at these two charts, we see the one on the left has a lot more in it going on than is required. You know, I personally believe in very simplified layout, so I remove lines and extra data ink. That's what the data visualization guru Edward Tuff calls it. Your mileage may vary on that, but one point here I just want to make sure that you understand is that if we see these curved north, south, east, and west, and you've probably seen this in your own work, much more embellishments, this one on the right is much easier to read. So even if you can't organizationally, or even if you can't bring yourself to get to this point because you have reasons for adding in certain embellishments, keep that in mind at least, because we should try to move away from embellishments. We should always try to stress data results and model results. So just a review on why any of this matters is that extra images, embellishments, they all increase the file size, and they're not necessary to help us present the problem. They're just sort of technology getting in the way for the sake of it. Presentation without distractions increases comprehension. There's tons of research to suggest this, and bad data visualization is going to decrease comprehension. And that's important because if you can't communicate what you're doing quickly and effectively, then you're not really serving your audience well. And finally, on this layout and design side, and I've always had pushback, especially from the auditors. Keep those instructions out. You don't need to put detailed instructions in your file, in your spreadsheet file. You should put instructions, small instructions saying click here, do this, perhaps steps that naturally follows the progression of how a user would use it. But you don't need those big tomes of instructions. Put that in Microsoft Word. Word is the word processor. Put that where you can have hyperlinks and tables of contents. There's a reason why when I wrote my book I didn't write it in Excel, I wrote it in Word. So in the same, you can also put it in PowerPoint. I'm a big fan of that because visually you can lay things out and you can again add hyperlinks, print it as a PDF, and those hyperlinks stay, they can jump around. Very, very effective, and specifically much more effective than having it in Excel, because if you do it in Excel, you can't use the model and look at the instructions at the same time. So let's move on to mechanics. So we need to design for readability. You need to design your formula such that others can read it quickly and effectively. You also need to root out spreadsheet errors. Many people don't know this. Those spreadsheet errors, those div 0 and value errors that you thought, well, you know, I know it's dividing by 0 right now because I haven't put any data in. Well, those errors grind your spreadsheet to a halt. They make things very, very, very slow. So make sure you handle them. You need to avoid volatile functions. They're also slow. Volatile functions are ones that recalculate at every volatile action. What do I mean by that? Well, if we were using the function rand, it would always produce a new random number. So that's a volatile function at every recalculation. So F9 is a forced recalculation, but if you insert you know, a column, if you write something on the spreadsheet, that is a volatile action that will cause it to recalculate. Now, rand, we will always want to recalculate because that's what we want with random numbers. But certain things like offset and indirect, those are volatile as well. Why? I couldn't tell you, but they are, and because of that, they're also very slow. What's more slow than just a few of them is a lot of them, so they slow things down exponentially. We should always avoid complex ifs. Ifs are probably the most overused, according to Excel hero Daniel Ferry, formulas in Excel, but really they also add complications, because when we look at our work later, we see, oh, these nested ifs, what did we do? And there's ways to create more natural formulas. Now, the extent to which you do that, and we'll see some examples here, that's really about thinking about the core problem and how these formulas represent it. How are they natural extensions of the underlying problem? So we want to design for readability. I have this formula up top here. It's a nested if formula. Now, I don't know how many of you know this, but in the formula bar, you can hit Alt-Enter, and you can use spaces to actually lay these formulas out. So at least if I'm using a nested formula here, I can use some spacing in much the same way one might do in programming to make it much easier to understand. So make sure you use that judiciously, or no, I shouldn't say judiciously, use that liberally, because it's very important to understand what's going on, and I think it's very well understood that the formula below is much easier to read than the one above. Now, let's talk about named ranges for a second, because named ranges are still named in the same way that people use VBA. People will say, well, val count for the value that's count. And I don't really know that you need the word val before it because count describes what it does. But even worse than that is when we give named ranges names that don't really make any sense, or they only make sense to us because we give them variable names. But remember, if we're passing our work on to someone else, it should be important to understand what they're doing. So here's a really interesting one and a really relevant one, given that Star Wars is coming out here soon. So I've named B6 the droids you're looking for. Now, if I read this formula as I'm presenting, I say if the droids you're looking for equals false, then move along. Now, you don't really have to be a grand Excel wizard to figure out what's going on. What is this formula testing? You see, it's not just that I've put in this formula what it does mechanically, but I've sort of expressed what we're looking for from it. So this is what I call semantic formula development. Now, we can't always do this because not everything's going to be a named range, but to the extent that you can do this, you should. Remember, your variable name should be descriptive. Don't just make them descriptive for you. Describe what they're doing. Okay, so the next part of this is rooting out spreadsheet errors. Sometimes you don't really know where they are, so if you are looking for them, you can go to the Find and Select and click Go to Special, select Formulas and select Errors and hit OK. That's going to highlight all the ones in the sheet. Now, once you know where they are, the real question is, what do you do with them? So if you can't really fix them, if you can't just delete them, what you should do, or if you can't fix the problem that describes them because they're a product of something that needs to occur, what you should do is this very easy fix. And that easy fix is to use if error. So surround what you're trying to do. So if I have A1 divided by B1, and I picked that very specifically because, again, these divisions are what causes that div 0 error. surround that with if error, and then you can actually produce a result if an error occurs. And if it doesn't occur, it's just going to return what it was supposed to do. So this is really important, super easy fix, and it will speed up your spreadsheet if you have a lot of these. Let's talk about volatile functions. So I say to avoid these. I know you can't get around some of them. For offset and indirect, you can often use index instead. It'll take a little bit of construction on your part, but in fact you'll see that it's easier to understand. And it's unfortunate that indirect, one of my favorite functions, it can be so slow, but it can be slow. So make sure you are really using index. A few here and there you may think is not a big deal, but it's worth replacing them in seeing, because one of the great things about Excel is that you can actually change things very quickly and effectively, much in the same way you cannot do with big BI vendor platforms. So for things like now and today, which produce current dates and times, you can often use VBA and just have that write to a certain cell. So if you have it write to a cell when it opens up, that's one cell write, that's one volatile action, versus today and now being live and just sitting there, that's going to be multiple ones. So rand, again, if you need, you can't really get around that one, but I leave it here as an example. You could move it to VBA, but if you are trying to develop random information, then you can't really get around it. And I only bring that up. I only bring that up because if you have been testing data, if you've been generating random data, make sure you get rid of it. But if you can't get around it and you're using it, remember, volatile formulas or functions have their time and place. So just keep that in mind. I say use natural formulas. So again, this is the notion of semantic formulas, and this is a very unfortunate example that resides in Microsoft's help. So if I look at this, I'm saying, well, what score did I get? What letter grade did I get? And here's how they actually use this nested if formula as an example of if formulas. Now, if I look at this and I wonder, A, B, C, D, and F, is the letter grade that I'm getting, does it follow that it's because I didn't get, let's say I get a B. Is that because I didn't get an A? Is it because I didn't get a C? Is it because I didn't get a D? No, not really. It's where I fall within a scale. So that's a scale problem. It's a lookup problem. It's not an if problem. So let me just look at this differently. I say that it's a natural lookup problem. So I have a current score. I'm going to match that score within the different bounded regions, and I'll just look back up what that grade is. So that's what I'm doing with the match and the index combination. It really is not, it doesn't require the complication of nested ifs. Now you may say, well, who cares? Well, look at this nested if. Do I understand what's going on? I sort of understand what's going on. If I look at this setup here where I have the grades and I have the scale, and I have an input cell, and I'm using match and index, it's a lot more easily understood what I'm trying to do. So remember this, your work should be a natural extension of the underlying problem. To the extent you've complicated it, you've not done well to present it. Now let's take a look at another example, a very common one. I have different products, and I want to know whether I'm dealing with an item size of small, medium, and large. So if I look at cell C7 on here, I have that if formula. Again, is the reason that I have a large because I didn't get a medium? No, not necessarily. So this problem is actually much better represented by using the choose function. For those of you who are new to choose, it works like this. The first argument is going to take an index, so in this case 1 through 3, and then you have given 3 items after that. So it knows that if you put in a 1, it's going to return a small. If you put in a 2, it's going to return a medium. Put in a 3, it returns a large. Notice how 1, 2, 3 in our minds matches much better with small, medium, large than this nested if. So here's when you should use nested ifs. When the problem naturally extends itself to a branching compounding condition. In non-technical terms, that means if I can draw a flowchart with it, then it's a natural branching condition problem. So if it naturally extends itself to a flowchart, then yes, that is a good nested if formula. Don't use them haphazardly. I would say don't use more than 3 conditions if you can get away with it, because after 3, our short-term memory can only hold 3 to 7 chunks in it, so I'm being a little conservative saying 3. But after 3, you're really taxing our short-term memory. And again, that natural understanding of what's going on is not happening, and it's going to be a lot harder when you pass that work along. And we know this about our working memory, our short-term memory, because of the work we've done in data visualization and the research that's come about. So let's talk about data visualization and presentation. This is a natural segue for that. So we shouldn't mislead with charts. Again, we shouldn't mislead with charts. We know that. We say statistics, we shouldn't mislead with them, but we often do because we haven't taken the time to learn just even a little bit of data visualization research. And if we do, we see that what we present is actually a lot better and cleaner and easier understood. We should avoid data occlusion. Now, that's the problem I've discussed with 3D charts. We should show relevant data together. Again, many people will take what they call a dashboard, and that will actually be 10 charts on 10 different tabs. We should look and say, do we need all those 10 charts? Did management just ask them, or do we really need them? And certainly we shouldn't separate them, because often they require the relevant context of the other information to be understood together. Again, learning some data visualization principles, I said a little bit, goes a long way. And finally, this is so important, we need to respect our audience's intelligence. Now, we so often hear, this is going to be a high-level talk. You need to talk to them like they're fifth graders. That doesn't really make any sense in my mind, because if they're high level, that means that they're in leadership. They've gotten to where they are for good reason. So that's not to say that there are loose ends. We should present loose ends that will engender questions and take the conversation away from what we're trying to present. But at the same time, we need to respect that they can understand what we're trying to do, because if the problem is a natural, or if what you're producing is a natural extension of the underlying problem, it's not an issue. We as humans understand this information. So let's go through some of these. The one on the left, we're showing the same data, and we're showing voting results. So the one on the left is a very misleading chart, because the axis starts at 40%. So this for and against, even though it's like, say, 45 to 55%, it overstates that proportion because we've zoomed in when we shouldn't have. Now we go to the right and we see that that proportion is not overstated. If you find that you're not starting your axes at 0, specifically for column and bar charts, then you can cause problems in how we understand information, because this proportional difference is overstated to what the data actually says. It's not a natural extension of the underlying problem. Now, here's just an example that I always like to show from Fox Business that shows tax rates. Now, we can debate the policies on this, but we can at least affirm that the data visualization research says that this is wrong, because the differences between 39.6% and 35% are not as steep as what's being presented. So always keep that in mind, and remember that the news media, your managers even, your friends, they may not have taken the required data visualization research. It's on you to advocate for the information. You are charged with presenting it well. So let's talk about 3D charts, and in particular 3D pie charts. If I said, hey, which slice is greatest here, you'd probably say the yes slice. And if I rotated that, you'd probably say the no slice. But in fact, they are the same volume. They're the same data being presented. So remember, just because we're presenting data, that doesn't make it correct. And that's what I was saying about models. Data on the screen, obviously, we know it's not always correct just because it appears on the screen, but even in the ways that we present data, we can overstate or accidentally misrepresent what's going on. So it's always important to get some data visualization research to help us understand the problems and folly of 3D, in particular pie charts. So I am looking at a 3D chart, and if I said, what is the value of product C sold by Rep 4 in region C, if you tried to look that up, as I'm trying to do here with my mouse, you cannot see what that result is. That is called data occlusion, and it happens when we use 3D bar charts and column charts, because we are occluding important data, and this is what happens when we use the 3-dimension. And in fact, there are ways around this. I urge you to take a look. If nothing else, we could actually split this up into 3 different charts. So it's worth not just taking this 3D chart because it's a default. It's worth thinking, hey, can I do the comparisons that I'm trying to do? Is the reason for this chart existing? Is it allowing me to do what's necessary at the end result? And the answer for that is no. So we should always try to show relevant data together. It's very common. So I have tornado data here. We have the full tornado data. We have all the years. We have the per month data. So if I wanted to turn all of these into charts, it would be very common, I've seen, to turn each one of these into its own worksheet tab. But we don't need to do that because we have Excel Sparklines, at least if you have 2010 and above. And you can actually do that. There are other ways to do that, but I would say Sparklines are the most popular and probably the best. And here we are actually representing that same information. We're doing it all at once. We can see it very clearly. That information can be understood in the relevant context of all the years very quickly and effectively without putting it on different worksheet tabs, which again we know by data visualization research that we're going to be taxing our short-term memory. Versus as we look at this happens very intuitively for what we call the pre-attentive attributes of data visualization. We don't actually use our short-term memory for this. It happens effectively how we take in information. And here I just want to show another example. This is one of a dashboard. We see that all this information can be understood together. So I've not split up these charts into other worksheet tabs. I've put them together so we can understand them in the relevant context. So just to do a little data visualization principles, how many 7s do you count? Can you count? We'll just take just a few seconds. Well, I actually don't really know the answer to this question, but I know an easier way is if I took those 7s and I turned them into alerts, and I said, hey, that other information is important, but it's not the most important. So now we actually see where they're located, and they're much easier to count. Again, the difference between this is that this is taxing our short-term memory. It's actually, we have to remember as we go through what we're counting. If we do this, it's much easier because there's a different part of our brain that understands pattern information, and we want to take advantage of that. And of course, if we make them all in one base, it's even easier to understand, and that's very similar to what we do when we chart. Now, let's take a look at this table. If I said, hey, what's the second highest month in this series? You'd have to go through each one. We'll take a few seconds and have you do that. Okay, so it's not actually easy, and it would be far harder if we had more than 10 data points as we have here. But if I said 1,000, you'd be like, well, I don't have time for that. But if we actually plot this data, we can look and see very quickly when is the second highest amount. Well, it's in June, right? So data visualization allows us to understand information very quickly and effectively if used correctly. And not only that, we can actually look at a lot more. We know where the lowest point is, we know where the highest point is, and we in fact see some seasonality. That is, it goes up January, February, it goes down after it peaks in March, and it keeps doing that. So we see there's some cyclicity within this data that we understand, and we understand all of that very quickly and effectively. And if there were 1,000 data points here and it looked like this chart, we would still understand it in the same amount of time, versus if we look at it as a table, it's a product of how much data is there, so we're limiting ourselves. So remember, take a little time to do a little data visualization research. I would strongly suggest looking at the work of Stephen Few and Edward Tufte, and that will help us out immensely. Now, here's a good rule of thumb, and I've seen this used quite a bit. So I have this fruits I like graph here. Now we have apples, grapes, pears, and pineapples. I have a line chart here. Well, line charts are used to show trend. This is categorical data, so there is no inherent trend within that data. So this is, in fact, wrong. So we need to understand as we present data that we can also mislead, even when we think that we're presenting the correct information. Turn this into column charts, and it actually makes a lot more sense. So let's talk about respecting the audience's intention. We need to use appropriately complex visualizations to model a complex idea. Now notice what I said appropriately here. That means we shouldn't be self-indulgent. If we're working on a tough engineering problem, that doesn't mean we need a tough, hard, complex engineering chart to represent it. We need to use what's appropriately sufficient such that it is a natural extension of the underlying problem. And then this is another item that we don't actually talk about when we talk about Excel and data, but we need to have confidence in the work that we do. And we can only have confidence to the extent that we understand it, because if we don't understand it, we can't present it to someone else. If you are able to push back against management when they say, well, I want to use a pie chart, and we need a 3D pie chart, at least show them alternatives, because seeing is believing, and we have been evolved to understand patterns in a certain way. So if you show them an alternate one, they will readily see the difference. Now that doesn't always mean you're going to win, but if you plant the seed and they argue with you, well, that will help us arrive at the position that we're in. So we'll understand what works, what doesn't, and why. And this is actually very important. Don't treat your audience like they're a bunch of idiots. Don't think that you need a pie chart because pie charts are simple and easily understood. Well, we know from data visualization they're not easily understood. They are simple. But don't just put something in there because someone else likes it or because you think you're smarter than someone. There's a reason that you've been tasked to present this information, so present it to an audience while respecting them. So let's just take a look at our goals before we finish out. Remember, we're trying to emphasize developmental memory. That's what did we do in our model, and if we pass it along to someone else, will we remember, will they remember, and will we be able to explain it to them when they ask? Model transparency. Have we built our model in a way that it exposes what it's doing and that we can quickly and effectively address errors? And finally, model efficacy. We can only create confidence in our work by having confidence in ourselves, and we do that by following research and by not overcomplicating things, but providing the necessary complexity sufficient to model a natural extension of the underlying problem. So remember, layout and design, mechanics and data visualization, presentation, those are the buckets I put them into. you may have different buckets and you may even disagree, but this is what we should be thinking about as we develop. And that is my presentation. Any questions?
Thanks, Jordan. Yes, we've got one from Todd Hayden. Do you know
Mm-hmm.
what is faster, self functions or VBA functions?
I think, I'm not an expert on that. Charles Williams would be the expert on which is faster. I would say in practice, formula functions are going to be faster because they were built for a reason. I am not necessarily a fan of user-defined functions. Sometimes you can't get around them. But to the extent that you can already use the pre-built-in functions, you should. One reason not to use user-defined functions is because you may give it to someone who is not a VBA person, and they may not understand what's going on. On the other hand, if you have a really complex problem, user-defined functions allow you to take that logic and make it linear in programming. So this is, I would say, which to use. I would say that formula functions are probably generally faster, but the broader question on which to use really depends on what the goal is and who's going to use it. And I only say that many people default to doing user-defined functions because they know they can create something quickly, but they're not always the best. And if you're using heavy iteration within those user-defined functions, you have lots of for loops, they're actually going to be slower. I mean, we know that because it's going to require processing from Excel.
Thank you for that, Jordan. And we've got one from Ian Payne. How can we get rid of the need to use linked workbooks?
That is a great question. That is an organizational problem. I would say that, I want to give you the canned answer, which is to say that you should move towards a BI platform that will allow you to just pull that information into Excel. What you can do is you should look at why you have these linked workbooks. If nothing else, you could go for the kind of ridiculous solution, that is where you hit an update button and Excel will run through a folder that has that spreadsheet, all those spreadsheets, and load it into Excel. And I'm a big fan of that because it puts it as raw data into the back end. In your raw, if you follow my information presentation or transformation presentation, we'll put it within your information areas of your spreadsheet. I actually prefer that solution a lot more than linked tables or linked spreadsheets, which are so error prone and problematic. I would say that is a short-term solution, but generally that's kind of an organizational problem. So Power BI, Power Pivot, those are, if you can get them to move their work over there and you use Power Pivot instead, that would greatly help reduce that. Now, I know that's a problem for a lot of people because you're all still using Excel 2010. I shouldn't say you're all, but many people are. It is the most used platform right now. So we're still probably a few years away from fully resolving that problem. And in the meantime, the VBA method is not my favorite, but the best workaround I can think of. Unless, if anyone in the audience can think of a better one or has solutions that they've thought of, certainly do share them with me. I would greatly appreciate, because that's such a crazy and widely and it's such a huge problem. We don't even understand it because many people don't know that linked worksheets. We're talking, by the way, for those who don't know, that when you link one spreadsheet to another spreadsheet file, it's just, there's a lot of errors that can happen. It's just not very good. Excel doesn't handle it very well. And what ways there are around that.
Cool. Next one. So Robin Barr asks, so do you recommend not using 3D pie charts as much as possible?
I recommend using them zero amount of time. I would 100% recommend against using 3D pie charts. I would generally recommend against using pie charts because from the data visualization research, we know that a column chart showing those percentages is actually going to do a lot better job because we can judge differences from column and bars better than we can judge the area differences within a pie chart. But you should absolutely not use 3D pie charts because, as I've shown you, how you present the perspective of that data is going to change what you're presenting. And this is very unfortunate because we know what the underlying data says, and then we accidentally change how we're presenting that same data using these different perspectives. So I would say 100% stay away from 3D anything because we're not modeling engineering variables here. There's no reason to have a third dimension except to say it's embellishment. We've told ourselves, I mean, I learned in school, hey, use this to make people interested in the work you're doing. Well, I mean, that's ridiculous. The work speaks for itself. We don't need to add embellishments. We just need to do a good job. Well, I was hoping someone would disagree with me. I was hoping someone would call me out. But if there's probably things in here that you're saying, oh, I know people have come up to me and they've said, oh, I wish more people would say that. In many ways, this is just my platform to complain because I can. But remember, there are things, this is only an hour long. There are things that I've not covered. Be the advocate. Be the person in your group who says it. You can approach it softly with the people who have strongly held opinions. But also remember as you do it that you're not always right in every situation. The advantage, what we take away is the conversation about it, because to the extent that we do a better job, we're going to prevent our organizations from spending all this money on a giant BI platform that really cannot deliver what we know we can deliver faster, more quickly and effectively in Excel. And when we build these things in Excel, we don't have to deal with the fact that if we're wrong, we've turned our back on millions of dollars of investment, or we've turned our back on this schedule that's overrun as we try to install this new IT platform. So really, I think Excel is the way we arm ourselves in, creating these outstanding models. That's how we're going to beat back that opposition. That's how we're going to show that this is actually a robust platform, and that the people using Excel are not, we're not the people left back in the 90s, as people often suggest. So this is very important because it's very cheap and easy to deliver these cloud platforms now they still cannot do what Excel does. And maybe when they can, I'll change my tune. But so long as they can't, it's on us to show people how, why, and to create good work.
Well, there's a second part to that question. Any tips that would help quickly understand complex data? And then while you're on that, there's a second one, and one of my favorites is, when would you use R and Excel?
So the first one was how to understand complex data. Is that correct?
Correct.
Just want to make sure I understood. Okay, so understanding complex data this is really more art than it is science. And it's really why having a wide breadth of knowledge of tools is important. So if you're in Excel, the first things you want to do is really understand the domain of that data. So why is this data, what are we trying to do with it? And that is itself not a data point. That's talking to the person who sent it to you, or maybe you already have that and you already have that skill set because you've worked in this area. But if you don't, that's the most important thing to do. Even though data is data, it doesn't really matter where it comes from. It generally comes in the same ways. So to begin understanding complex data, what I would do is really outline what I think I can get from that data. So why did someone give it to me, and where am I going with it? And then from there, I want to do things like look at the frequency distributions of whatever I'm trying to model, or even see, really, step one is to make sure that data is clean and ready to go, but we're going to just assume that it is. And ways to do that is with pivot tables, with data visualization, with charts. Now, Excel is not, unfortunately, the best data data analysis, exploratory data analysis platform. There are many. It is one that you should use in your range of tools. So I generally start doing visualizations first. I start pulling out, I define a segment that I want to do tests on. So let's say you're doing transactional data. I'll say, hey, this is the data I want to look at, and then I'll start doing I'll check out frequencies of things, I'll start looking at visualizations on it, and even bringing other people in and saying, hey, does this make sense to you? Now, another great platform for that is Tableau. If you've used Tableau, Spotfire, and of course R, you can do that, but R has a bit of a learning curve. Now, to answer that second question about when to use R in Excel, I have to say that I'm probably not the best person to ask, because I generally don't use them together. So when I use R and when I use Excel, I'll use Excel to get the data ready for how I want to do work with it in R. Much of what I do in Excel I can do in R, but I think it's much easier to get it ready in Excel because it's visual. So with R, you're typing things in, and there's so many different libraries, so you can just use the base R package and filter a column you want, or then maybe you can use dplyr. Every one of those has a learning curve, and that's the pain that is R. Now, what I'll do is I'll start out in Excel and I'll get it to where I need it to be, and then I'll bring it into R and maybe do a little bit of brushing up. Now, that's actually an interesting concept, because if we go back to this information presentation or information transformation presentation, we still can follow that within R, because we can do the information layer, the back-end piece, we can do that within Excel. and then we can bring it into R and make transformations on it, and then we can present it with ggplot or regular plot or whatever you want to do. But I have not. I know there's a future in which R and Excel will work together, and you can write scripts in R and to use them in Excel. But I've not done any of that.
Ooh, next one from Todd Hayden. Real question: the job market does not want Excel; they want BI. How do you tell them Excel is still good?
Ooh, what a great question. Well, you know, you are up against opinions on that. So the way you show them it's still good is really present, I would say, do a cost-benefit analysis, because generally these BI platforms are going to cost a lot. Now, I will say that you need to take a step back and ask yourself if you're just trying to use Excel because that's what you've learned, and you know, there's a part of this that's self-indulgent where we don't want to change and we want to create complex Excel things that might be better in BI. So in a BI platform. So just take a step back and ask yourself, really, is this problem better done in Excel? Now, if the answer is yes, or at least you think it's yes and you're not sure, then what I would do is actually look at this from a cost-benefit standpoint. If I can build something that's going to take me, let's say, a month in Excel versus installing this giant platform, we can cost that out. We can cost the differences that out and understand. And even if I can just build it, if I can prototype what I think that they want to use BI for, if I can prototype that in Excel, I can show it to them, say, hey, look what I built quickly and effectively. It's not hard for me to add on to these things. You're not getting, you're not getting what you think you're getting with these BI platforms. Now, I know from personal experience that you can do that until you run out of breath, and sometimes you're going to lose that argument, unfortunately. But every time you do that, you're planting a seed against it. And I think what really happens is, even when you lose that argument, there's an acknowledgement that Excel still has a place, and so that you don't always have to do, if you want to do quick and effective work, you don't always have to use that new BI platform, that you can still use Excel for turning things around quickly and effectively. I know that we're living in a world in which sometimes this is a losing game, and I can't give you, the silver bullet that's going to solve this problem, but we should try to the best we can to build great work in Excel and at least save our companies money, and at least show them what we can do, because even if you don't win that argument, perhaps you'll start your own little Excel clique, which often happens in companies, and there's going to be a time and place for the work you do, that even though the BI business developer came in and said, hey, it can do this better than Excel, you know that it can, and you can own that piece that it doesn't work better in Excel, or I should say doesn't work better in BI, so you can still deliver the best solution.
And one last one before we wrap it up.
Mm-hmm.
Power Pivot is available for Excel 2010. Yes, it is.
Mm-hmm. It is, but not as well. It's not as good as the later versions. And I have to say, this is very unfortunate. Having done Power Pivot in a 32-bit environment is just, well, I'm just not sure if I recommend it. Now, if you're doing something big, and again, this is something that Microsoft should hopefully address here soon, but the 32-bit environments are a huge pain, and at my old company, they would not update to 64-bit. And it really is a problem, and I'm not sure, there really wasn't a good solution, unfortunately, but I think in time these problems will, I would say we're about 3 years away from solving all those problems. But stick with it, please, stick with Excel, because when it comes, you'll really be delivering better work than these other platforms are delivering right now, or even in 3 years, because Microsoft understands the value of Excel. They understand that the real solution is linking it to that back-end Power BI, or that back-end BI system.
Cool. So thank you guys for attending. If you'd like to see more of Jordan, he'll be presenting data disasters, how data visualization and complexity led us astray at the PAS Business Analytics Summit conference in 2016. So the BA Marathon was brought to you by PAS. So thanks again for attending. And next up is Ginger Grant on implementing database decision making. Thank you, guys.
Yes, thanks to everyone, and feel free to reach out to me on your own time if you'd like.